Hello, hello everyone. We will continue with our the sign conventions of shear force and bending moments. During last video, we have learned how to find the reactions at the supports A and B. Now, in this lecture, we will see what is shear force and where we will determine it. What is the moment that is taking place at the point. See, anywhere we need to take the section like this XX, either here or exactly after this load here. You should take section, you section it anywhere. You will find the next figure will be like this. Now, this is the next figure. Uh, Here in this problem, in this analysis, the sectioning is shown in between C and D. Some sectioning is taken, just a section plane you just take, represent the section plane, and see this. You draw the free body diagram separately. Uh, this is what is happening. You see, from left portion we have drawn a separate figure. For right portion we have drawn a separate figure. So to find the forces experienced by the section, consider any one portion of the beam. Taking left hand portion, transverse force experienced 8.2 minus 5 is 3.2 kilonewton upward. 3.2 kilonewton upward direction. 3.2 kilonewton. Why 3.2 kilonewton? It is, see the resultant force here, 8.2 kilonewtons minus 5 kilonewton. The remaining is 3.2 kilonewton. It is acting. You need to take in upward direction. It is acting because 8.2 kilonewton is greater than this 5 kilonewton. So the resultant force will be in upward direction only. So 3.2 kilonewtons in upward direction, and the moment experienced here is it is 8.2 into 6 minus 5 minus 5 into 2 at the point. What is the moment it is experienced? So you should consider, see the sectioning is taken place at 6 meters, so that's why we are considering this distance. So this distance is 2 meters. So the moment, you can find the moment at this section as 8.2 kilonewton into 6. So this direction is clockwise direction. Here you assume a clockwise as positive, and 5 into anti-clockwise is negative. Clockwise and anti-clockwise. So the resultant moment will be 39.2 kilonewton meter. So the final direction is clockwise because 8.2, because this is positive. When it is positive, it is clockwise direction according to the figure shown here. If we consider the right hand portion, the coming to the shear force, how the shear force will be, exactly it will be opposite to this one, because it is a reaction force which is not allowing the member to shear off. If forces are existing, but the body is not subjected to permanent deformation, that's why we get the reaction forces. Simply you can say that the forces opposite to the what we have found here, it is 3.2 kilonewton upwards, and in other side, right hand side, It is upward. Now right hand side it is downward, and it is clockwise. The movement is clockwise, and here it is anti-clockwise. So if you want, you can check it again also. So 10 kilonewton downward, 8 kilonewton downward, 10 and 8, 18 minus 14.8. It is 3.2 in downward direction. 3.2 kilonewton in downward direction. Coming to the moment calculation, clockwise is positive. You take clockwise. We consider clockwise as positive here. 14.8 kilonewton into 9, anti-clockwise it is negative. Next clockwise 10 into 9 minus 5 plus 1 6, it is 3. 10 into 3 plus and 8 into 8, here 8 into 8, 5 plus 3 8. So 8 into 8 and 10 into 3. Just calculate the movement. That's it. We here we got minus magnitude, minus sign, magnitude with minus sign. So negative sign indicates that the direction is anti-clockwise. See, we got here it is clockwise, and then on the other side it is anti-clockwise. While we are finding the shear forces, no need to calculate twice. Anyone you can select and you do the calculation part. And that is shown here. You see 32 kilonewton upward and the bending moment is in clockwise. 32 kilonewton downward, the bending moment is in anti-clockwise. These two are reaction forces, reaction to each other. One is action, other one is reaction. So that's why the shear force will be the magnitude of shear force is 3.2 kilonewton, but 3.2 kilonewton. It is restricting. It is not getting deformed here. Now, thus the section XX considered is subjected to forces 3.2 kilonewton and the moment 39.2 kilonewton meter, as figure shown in figure. The force is trying to shear off the section and hence called shear force. What? The force which is shearing a member is called as a shear force. The moment bends the section and hence called bending moment. The moment which is bending the member, at that particular point, how much bending moment is there means 39.2 kilonewton meter. So the bending, one bending is in clockwise, other one is anti-clockwise, the reaction bending. So this is how the sign conventions and the bending for shear force and bending moment is taken. Next, shear force at section. Algebraic sum of vertical forces acting on the beam either to the left or right of the section is known as shear force at the section. Bending moment. Algebraic sum of the moments of all the forces on the beam either to the left or right of the section is known as bending moment. It is already we discussed. It is just algebraic sum of the forces, vertical forces. So sigma Fy, I said Fx or Fy is equal to 0. Algebraic sum of moments is 0. By using that, you will find out the supports. Now, 3.2 kilonewton upward, 3.2 in downward. So shear force is shown like this, force up and down. A bending moment, you just draw a line and you can show like this. So it is now movement and bending moment. What is movement? Movement means a fan which is about to rotate is a movement. It is taking a movement. When the member is fixed, it is not moving due to the moments that are acting on the body will create bending. Bending moment is the moment which causes the bending effect on the beam is called as bending moment. It is generally denoted by BE or epsilon. What is a moment? Moment is The product of force and the perpendicular distance between line of action of the force and the point about which the moment is required to be calculated. Force into the perpendicular distance is the moment, and the direction is calculated by rotating the force towards the moment center, moment point. So that is movement. So when this movement is causing bending, is called as a bending moment. So this bending takes place when you hold firmly. There is a member, there is a beam. When you hold it firmly and you apply some forces due to which the bending moment is acting on the body. Movement is acting on the body. So due to which, due to these supports, firm supports, will get bending it in this direction, or it can be upward or downward. Coming to sign conventions, it is upward here. It is shown this as upward direction, and downward direction. This is reaction one, so it is positive. They consider it as a positive, and this as negative. The bending moment is considered as sagging bending moment if it tends to bend the beam to a curvature having convexity at the bottom as shown in the figure. Sagging bending moment, positive bending moment. Loads are applied, bending is taking place like this. If you find a bending like this, it is sagging. We call it a sagging bending moment. Generally, when we keep a low beam on a two supports, you will find bending at the center. It will be bend in the center. So you will find a curve, a convexity at the bottom. Convexity, and that is called as sagging. And we consider it as positive bending. Hogging. Convexity in upward portion, in upward direction, this is negative bending. So bending is taking place like this means bending moment should be like this. So one is in this direction, other one is in this direction. So it is bending it. Similarly, the bending moment is considered as hogging bending moment if it tends to bend the beam to a curvature having convexity at the top as shown in the figure given below. Hogging bending moment is considered as negative bending moment. It is considered as negative bending moment. Next, shear force and bending moment diagrams. Shear force diagram. The diagram uh, it shows variations in shear force across along the length. That is shear force diagram. See, the diagram which shows the variation of shear force along the length of the beam is called as shear force diagram, and the diagram which shows the variation of bending moment along the length of beam. So diagram which shows variation in the bending moment is bending moment diagram. Shear force diagram. Point of contraflexure inflection point. It is the point on the bending moment diagram where the bending moment changes the sign from positive to negative or vice versa. While drawing bending moment diagram, it will cross as the uh, uh, that is zero line. It crosses the zero line, null line. So the point at which the bending moment changes its direction either from positive to negative or negative to positive. It is called as point of contraflexure or inflection point. It is also called inflection point. Inflection point. At the point of inflection point or contraflexure, the bending moment is zero. That is what I said. It is zero at the point. We will see the relationship between load, shear force, and the bending moment. We will see one problem that directly we will enter into the problem, an example problem. Draw shear force and bending moment diagram, SFD and DMD for simply supported beam subjected to 3-point loads as shown in the figure given below. So you are having a simply supported beam AB which is acted upon by three forces vertically downward, 5 Newton, 10 Newton, 8 Newton at distance 2 meters from A, and between CD 2 meters, between DE 3 meters, from E to B it is 1 meter. First, uh, let me tell you the steps first. First of all, find out, first step, determine the reaction forces. How do we find the reaction forces? It is very simple. As we discussed earlier, summation of vertical forces is equal to 0, and the moment at any of the support, any of the unknown reaction is 0, you consider. Then we will find the reaction forces. But in this case, the reactions will be in upward direction, RA and RB. RA plus RB is equal to 5 plus 10 plus 8. 15 plus 8, 23 Newton. 23 Newton in downward direction. RA plus RB is equal to 23. And the moment at A, you consider it as 0. So 5 into 2 plus 10 into 2 plus 8 into, 10 into 4 plus 8 into 7 is equal to RB into 8. So that is shown in the next figure. Using the condition summation of moments at A is equal to 0, you take consider clockwise as a positive. Now this is the moments here. You can find out the reaction RB simply by using this bending moment equation. Summation of moments is equal to 0, and summation of the forces, vertical forces, is 0. And we can find out RA and RB. RB is 13.25 Newton, RA is 9.75 Newton. So you need to focus on the numerical values here. Both are in upward direction. We need to consider sections different uh, at near the loads and the supports. We need to take the sections and we should analyze for the shear forces. Now we have section 1 near A, 2 near 5, 3 near 5, but it is right side, and 4 on the right of this 5 Newton near 10, 210 it is left, and right side we have right of 10 we have 5 section 5 and section 6 at 8 near 8, right side of 10, and 7 7 to right of 8, 8 8 to the left of the support, right of the 8. Shear force at the section 11 is denoted as V11. Shear force at the section 22 is denoted as VT2, and so on. V00 is 0 because there is no shearing force, there is no body here. So V11, when we consider V11, you cut at 11, the upward reaction force 9.75, that's it. So the resultant force here, the shear force that is acting is upward, in upward direction 9.75 Newton. So upward direction we consider it as positive. 9.75. Next at V22 also 9.75. You take section here or here, anywhere along this A to B, anywhere you take the section, you will find the same magnitude for shear force. 9.75 Newton. 9.75 Newton. V22 is also next. V33 9.75 minus 5. It is upward. It is positive. 4.75 is positive upward. V44 is also 4.75. Next V55 15 9.75, it is minus 5.25, it is in downward direction. So point of counterflexure will be at this point only, where uh, in between 10 and this 5, near to the 5, or in this 5 to 10 to 8 point of counterflexure we will find, or inflection point. Next V66 is minus 5.25 Newton. Same. Now V77 here 5.25, V77 here it is V66 is minus 5.25. 10 V55 is 4.75 minus 10. The direction of shear force here at V44 is shear force direction. Anyhow, it is summation only. So that's why he's taking this one. Directly he's taking 4.75. So the magnitude here it is 4.75, here it is upward. So upward minus 10 is minus 5.25. So till here, so at section 55 it is minus 5.2566, 5.25 only. Now 77 it is minus here, minus 5.25, minus of 8, it is minus 13.25. Or you can see the right side, 13.25 upward, and you have no force here in this section. At 77 or 88 there is no downward force. So DE, in DE section, so only upward section, that is that 13.25. So it is negative. And V99 is 0. There is no shearing here. Next, coming to the shear force diagram, we have 9.75 Newton here, and so V11 at different sections, whatever in the portions, that is A, B, we have different sections A, B, B, C, C, D, and D, E. At different sections, we are getting the shear force values. See here, it is positive value 9.75 till C only. Next, till D, we got 4.75, and point of contrafracture takes place at the point D. The magnitude here it is minus 5.25 Newton. It goes till E. Again, it is 13.25 at the end B. So this is negative and this is positive. So this is shear force diagram. Next, bending moment. Bending moment at A is denoted as MA. Bending moment at B is denoted as MB, and so on. MA is 0. See here, just remember this figure. At A, moment is 0. But during first section, he's saying that it is at C. It is 9.75 into 2. AC DEB. At C, the upward is 9.75 into 2. So it is in clockwise direction. So we consider it as positive. And at D, similarly at D, E, B, we are getting the bending moments values. Now at D, the second one at D, it is 9.75 into 4 minus 5 into 2. Just resultant movements you need to take. Resultant movements at that particular point you need to consider. Points of forces acting. So first one is at A, C, D, E, and last one is at D. So we get the values 19.5 and 29, 13.25 Newton meter, and B here it is a 0, and MB is, since it is simply supported, so the moments at the supports is 0. Finally, we get the figure. So the bending moment, it is shown with the lines. You just keep the points first. Here all are positive values because we got all in a clockwise direction, positive values only. So 19.5 Newton meter, 29 Newton meter, 13.25 Newton meter. So when you join them by lines, we get the bending moment diagram positive. So the diagram is showing values in upward direction, but in general analysis, how the bending will be? The bending will be in downward. It will bend like this. You will find shagging. When it is in shagging cases, here you will get positive. The bending moments are positive. In hogging, it is negative. So overall, we should represent the bending moment diagram and shear force diagram like this. Over the exact length, you should represent, uh, draw, draw a line. So you should represent like this only. Draw the line, and these are the shear forces that are acting like this, and you will find the bending moment diagram. So for UDL, We will see in the next video lecture, we will see what is UDL and its analysis. Same, how to find out the shear force diagrams and bending moment diagram. The thing is, calculation part is required. Do the calculations properly. Sign conventions are important here. So I want to revise that sign convention once again. We will go to sign convention. To the section to the left side, if it is in upward direction, it is positive. During sign convention for shear force, we have a section here. To the left side in the direction of resultant forces, if you have shear force in upward direction, it is positive. To the section and the resultant force is right side of the section, then it is negative. To the left, it is positive. To the right, it is negative. So this convention is important. This we should remember. For sagging, it is positive, and for hogging, bending moment, negative. We show it as negative. Bending moment diagram, the graph will come in downward direction. In the example problem that we have seen, it is sagging. The convexity is in downward direction. So the bending moment diagram will be is positive and above the horizontal line. That is what is shown here. See, here coming to, first of all, we will see the sign convention for shear force. See, here you should come only in one direction while doing calculations. So we got a minus sign in one direction. It means point of counterflexure is taking place at 5, 5. Once you have found the point of counterflexure, then the other are also same, negative only. So we do expect the other forces. If you are having a force from downward, then we can expect some other disturbances. But there is no forces from the downward, only from the top you are having. So we have minus 5.25 newtons. Then at the section 6.6 minus 5.27, and at 7.7 minus 5.27 and minus 8. And the difference between these two will be added up, plus minus 13.25 minus 13.25 and this is plus already. From the bottom upward is plus we are taking, and finally we get the figure like this. And we will see the next problem, UDL, uniformly distributed load, in the next session.